Hello, so this question is find permutation. So permutation, I mean, that definition is pretty straightforward. So when you see Si equal to I, you want to make sure this is increasing order. If Si equal to D, you want to make sure it's decreasing order. And then for this one, example 1, length of S is 1, return output is in array length of 2, this length of string S is 2, and then you return length of 3 for the output. Alright, so here's it. What you need to do is, let's not care about what is the output right now, let's care about the input length. So if input length is equal to 1, you want to construct the in array to length of 2. So 1 and then you plus 1. So basically it's in array, and then the size is going to be s dot length plus 1. So I will have a default all the way to n and then plus 1. So 1, 2, 3, 4, all the way to, so this is n and n plus 1. So this is n, right? And then n plus 1. And then what you need to care about is if s equal to I, the current index equal to I, you don't care about it because the default is already increasing. And if you see there's a decreasing, you want to swap the index that you are trying to fulfill this constraint. So let's see, s equal to I, D, I. So let's say, so the default is the length of 5, so you construct length of 6 in array. And let's see, first I will fulfill this, that's correct. Second I will fulfill this is correct. And then this will be D. D has to be decreasing order. So at this index, you need to swap. But when you swap, you want to make sure the previous I, this is I, right, also needs to be increasing order, which is correct. And then later on, it will be another I over here. So I will be 3 and 5, this increasing order, and another I. So this will be a 2-pointer solution. So let's start coding. So the result will be equal to new in s dot length plus 1. And then return result. And then I will construct the string. Result I will become I plus 1, starting from index 1. I mean, starting from the value 1 at index 0. So I will have a 2-pointer I equal to 0, I less than start length, I plus plus. And I will create another pointer based on what the current I is located, while the I is less than start length, and the current character at I is equal to D. Basically, I want to increase in my I. Yes, I want to increase in my I, and then J will become smaller than I, right? And then what I need to do is I want to reverse between the J and I. Imagine I is smallest, okay? And let's write reverse. So reverse will be pretty straightforward. So I will increment, J will decrement, right? And after that, it should be the answer. Okay. Yep. For the time and space, this will be the space all of n, right? For the time, this will be all of n. This will be all of n. And then if you need to keep swapping, this will be all of n. So worst case, I'm talking about worst case, it's going to be all of n squared. But again, when you swap, this will be another, the index. But that doesn't matter. Once you have this one and this one will be the same time complexity for sure. And the worst case will be n squared for the time. But average case, I would say all of n. But again, like worst case. All right, using this idea, we can construct a stack. So I'm just start coding, and then you just follow them. And we still need to make sure we return the result. So in J, we still need to be declared. Starting from index 1 all the way to the last value, last index S. So if S.char I is equal to I, so I want to make sure this is increasing order, else it's going to be decreasing order. So stack.push AI will happen at any scenario case. And if this happens, then we want to make sure if the stack is not empty, we want to assign the value into the result. So while stack is not empty, assign the index. So starting from J, because J is index 0, I will be starting from 1 and then all the way to the end. So we want to assign that and equal to S stack.pop. And then after that, we want to make sure we push the last index. And while the stack is not empty, then you just keep assigning. So you might be wondering, how do you care about the character D, right? So character D is just push into a stack, and then if there's I, then I will just write in the value accordingly at the correct spot at J. So imagine this. So D will be the first index, so I write my stack equal to 1 over here. And then another one is I. The following one is I, right? So I'll push another one, which is 2. 2, 1, right? So 2, 1 is currently right here. So J will be index 0, right? J will be index 0 right here. And then I pop the whole entire stack. So 2 will be the first, 1 will be the second, and then J will follow, J will increment based on the stack pop, right? And after this, I want to make sure I have the last value, which is going to be 3. I push and then I pop for this. So 2, 1, 3, that's how I come from. And then let's see. So A start char, probably I don't. So this will be I minus 1, my bad. So A start chart at a I minus 1. So this will be represent the S, and this will be represent the stack for the in array. All right, so this solution is a little bit tricky. I still prefer the first solution. Time and space will be all of n, time will be all of n, and then pop will be, the worst case going to be all of n, and this will be n squared, will be the same, similar. This is pretty tricky. All right, I want to try one thing. If I do this and I don't care about the else, this is still working. It doesn't matter is I or D. They still have to push into the stack, and this is how you care about when the current character is equal to I. So if I take I away and then come back here and like this might break. Oh, it's still passing, that's fine. So this would be the ultimate solution. What else? Yeah, this will be the ultimate solution. All of n and then all of n, and then square for the time, all of n for the space. All right, see you later. Bye.